And don't tell me this isn't part of your development, I won't believe you. Hey everyone, today we are talking what very often seems like a waste of time, and very often it is, namely how to implement keyboard shortcut Ctrl Z and Ctrl Y in your LWC component. In this case, we continue to talk about our application, and therefore we will implement this feature for our filters component, where we specify record filters, and as you can imagine, there can be a lot of them. And so it's important that the user can go back in time. Let's get started. This is the result we are going to try to get to. This is our component. We add fields, condition, values, and at any point in time when we realize that we deleted something by mistake a few actions back, what we do is we press Ctrl+Z and the component returns to the state it was in before the last change. And we do this again and again and again. Then we realize that in fact everything was fine. And now using Ctrl+Y, we return to our most recent state. The logic filter here in the corner also follows us on this journey because it depends on those filters, and therefore it makes sense to control its state as well. Let's move on and talk about the design. I want to make this redo and undo features reusable for any component. At least I have already two that I can apply it. So we will create a separate utility.js class which will contain logic not tied to a specific component, and which we will import when needed. If you look at existing project, you will see that I already have two utility classes, one here and one here. Why create a third one, and why don't I add this logic to the existing ones? It's all about a single responsibility principle. Your class or module should only have one purpose and be responsible for only one thing, right? Don't get me wrong, it's great to create a separate utility class with reusable functions, etc. But it's even better when you can create several of them, where each is responsible for one thing. This way you avoid creating a god class, one utility that has everything and is unrealistic to maintain and understand. I already created a new utility, and the first thing I do is create two weak maps. The first one will store the state for a specific component, and the second weak map will contain the event listeners for a specific component. I use a map because I suspect that this utility can be used on the same page by different components, and also Lightning Web components always look modular and encapsulated to us, which they actually are. Imported JavaScript modules are singletons. For example, if you have a component A that imports a utility and component B that imports the utility, these two components will interfere with each other, overriding and confusing data in the utility. Also, if you are wondering what a weak map is, think of it as a regular map but optimized for the garbage collector. That is, if we used a regular map right here, the value would be stored even when our component was destroyed. But in case of weak map, the garbage collector will clean it up. This is actually a serious problem called memory leaks that we don't really pay attention to, and it means that we continue to store the value, variable, or whatever it is, even when we are no longer using it. Why? What I do next is create an object, I think it will be more convenient, which will contain register and unregister functions. Accordingly, in the register function, I expect to receive a component instance. I need something to distinguish those components for the map, right? So let it be component instance, as well as certain options, or in other words, the configurations that a specific component will specify. And I expect this options parameter to be passed as 3 identifiers. I'll show how a specific component uses a bit later. Bear with me. Next, the most important thing. The best way to store the states of your component will definitely be a stack. This visual representation gives a good understanding of how this data structure works. You put the first element on the stack and it is placed at the very bottom. Then you put another element on top, and in order to get that first element, you first need to get and remove the one above it. This is great data structure when we need some clear sequence and priority of the last element over the previous one. This is actually how the redo and undo operations work. You don't jump from the last change to the first ones and to the middle, right? You just roll back your changes one by one, meaning you take the top element of the stack. Next, we need to create a function that we feed to our event listener when a key is pressed. We add a condition that we really care only about a control, and also add if-else conditions if it is Z or Y. Then I want to specify event prevent default for both of them. This is more of a protection measure, since for example the div container doesn't have a standard behavior, but there is a nuance. If you're inside a container but have focus on the input, it might not work as you expect, so let's keep it here. Keep going to the main part of functionality, where in case of Ctrl+Z, we need to determine if the undo stack is greater than 1. And if so, then we remove the top element of the stack using the pop function, meaning we remove the current state of the component where we are right now and move it to the redo stack so we can go back and forth if necessary. Then we need to take the last element of the stack and set it as the current one. Makes sense, right? The stack doesn't have a function to just take the last element. There is only a pop function that takes the last element and removes it, but we need just to take it. So I'm going to create a separate function somewhere around here where I'll pass the stack as a parameter and take in a not so stack-like way the last element. And then I'll go back and call this function right here. And after we call the setState function, which will be part of the actual component, bear with me, and provide the new state. And here I'll probably also create a new deep clone function to clone the state of the component to make sure that we don't have any unnecessary dependencies. Now, there is a problem here. We added the conditions that the undo stack must be greater than 1 for the reason that the first state of the component should always remain like the initial one. But we didn't specify that first state of the component. That is, I'll go back somewhere up and add to the undo stack the current state of the component, which is described by the getState function, which was passed to us from the actual component. Now it makes sense. Next, I'll do the same, but in the case of Ctrl Y. Remove the element from the redo stack this time, add it to the undo stack, so that again we can go back and forth in time and set the new state of the component. We have finished describing the functions that will be called when a key is pressed. Now we add event listener on the element and specify this function. Also, don't forget to set the top index of the element to 0, which actually makes this element focused. Otherwise, the browser will not catch the keystrokes. And another function that needs to be added, let's call it push state. It will be called by the component itself in case it needs to provide a new state of the component, because everything we've done so far assumes that a component will regularly send us new data so we can add new elements to the stack accordingly and track all the changes, history, etc. And it looks like the utility is ready to go. Let's now see how the component should configure this functionality. I already have the code for this. That is, in our component we import this newly created utility, which makes sense. And the first thing we need to do is register it. We use the register functions that we created, and here we define those 3 identifiers that didn't make much sense to us in the utility, namely element, which is a container on which those listeners needs to be added. In this case, I use the topmost div container that I have in the markup right here. After that, in getState, we pass all the variables of our component whose state we want to monitor. And in setState, we assign the new state of these variables to our actual variables in this component. That is, when the utility at any point calls the setState function, it provides from the utility somewhere from the stack exactly those variables that we specified here in the getState, but with the actual values that were before, somewhere from the stack earlier. And accordingly, we need to assign those earlier values as the current ones. Last but not least, in different places of our component, we call the push state functions to track the history of our changes. For example, if the user changes a field, we provide the new state of the component. Removes the filter, same. And so we do for all existing actions in our actual component. Let's take a look again at how it looks. Our components have been loaded, which means that our utility has been registered and the first initial state is already stored somewhere in the stack. As soon as we add something new, the push state function is called, which provides the new values to the utility. And when we press, for example, Ctrl Z, we remove the current element from the stack, take the next one and set it as the current one. And also add the previous state to the redo stack, so that when I press right now Ctrl Y, we return back to the state where we were. You can find the code for this utility and its usage in the repository that I'll leave in the description. Thanks for watching, don't forget to subscribe to the channel, and I'll see you anytime soon.